Welcome to The Explainer. So today we're going to talk about a really fundamental shift happening in artificial intelligence. We're moving away from these models that are basically set in stone and into a new era of systems that can actually learn and adapt on the fly. So let's jump right in. You might be wondering, why do our smartest AIs seem to be hitting a wall? I mean, they're incredibly powerful, right? But for some reason, there's this performance ceiling they just can't seem to break through. Okay, so the problem really comes down to what we call frozen AI models. The name kind of gives it away, right? Basically, once they're trained on a huge data set, that's it. Their learning phase is over. They're static. And that creates some major bottlenecks for making real progress. And this is where you can really see the limits. I mean, think about it. First, these models literally can't get any smarter than they were on day one. Second, if you try to feed them a huge amount of information, like a super long document, the cost and the time it takes just explodes. It becomes completely impractical. And maybe worst of all, when they face a totally new kind of problem, something they weren't explicitly trained on, they just fall flat. So what's the fix? Well, it's a huge shift in thinking. It's called test time training, or TTT for short. And honestly, this is where AI is about to get a massive upgrade. So what does that actually mean? Well, instead of the AI just being this static tool that you use, it becomes a dynamic system. It literally learns from the very problem it's trying to solve as it's solving it. I love this analogy. It's kind of like a mechanic who learns about a brand new engine by actually working on it, right there in the moment. And this is such a powerful way to think about it. We have to stop seeing a model's weights as some fixed static thing, like an encyclopedia. Instead, we should think of them as this hidden state or a high-capacity memory buffer that's always evolving with every new problem it sees. Okay, but here's where it gets really interesting. This whole live learning idea isn't just one single path. It actually creates a fork in the road, leading to two really different, really powerful approaches. Each one is built for a completely different purpose. All right, let's go down path number one. This is what's called the Discover engine. And the best way to picture this is to think of a deep sea explorer. Its mission is to find one single priceless treasure deep on the ocean floor. It's all about that targeted, high-stakes search for a breakthrough. And yeah, this is not for your everyday, simple tasks. We're talking about a super high-value tool here. It's designed to crack really specific, really complex R&D problems, like, say, discovering a totally new algorithm or a way more efficient piece of code. So that $500 price tag you see, that's an investment in a single, massive breakthrough. And the results? They are absolutely incredible. People are calling this an Alpha Zero moment for science. And you can see why. This approach is achieving state-of-the-art results across the board. In math, in biology. I mean, look at this. It discovered GPU kernels that are twice as fast as anything that came before. It's beating top-tier human experts and even huge proprietary models like GPT-4 in these very specific domains. It is a genuine leap forward. Okay, so that was the Explorer. Now let's look at the second path. This is the E2E compressor. And if Discover is that deep-sea explorer, think of this one more like a universal translator. It's not about finding one thing. It's about handling a constant, massive flow of information and doing it with incredible speed. Yeah, so the goal here is completely different. It's not about discovery. It's about taking in just massive amounts of context. We're talking huge documents, video streams, you name it, and compressing all of that understanding directly into the model's weights so it can be recalled instantly. But, of course, there's a trade-off. There's always a trade-off, right? The prize is huge. You get a nearly 3 times speed up when you're actually using the model. That's inference speed, which is insane. But here's the catch. You have to pay for that speed up front. It takes over 3 times longer in the initial training phase to get the model ready for this kind of work. So when you put them side by side like this, you can really see how different their philosophies are. You've got TTT-Discover, the Explorer, which is all about hunting for that one big win, the maximum reward. And then you have TTT-E2E, the translator, whose success is all about how well it can understand and compress a huge amount of context. And this gets down to the core of how they work. Discover is all about trial and error. It's in this loop. It tries something, gets a reward signal back, and adjusts. It keeps doing that until it finds the absolute best solution. E2E is totally different. It's in a continuous cycle of prefill, decode, compress. Basically, it's always reading, understanding, and then packing that understanding away. This difference even shows up in what they produce. Discover gives you something concrete, an explicit artifact you can actually use, like a piece of Python or C++ code that you can verify and run. But for E2E, its state is an implicit memory. It's this hidden understanding of everything it's learned, stored right inside the model's own weights. You can't just grab it. Okay, so this all leads to the big practical question, right? If you're someone who's actually building with this stuff, how do you choose which path is the right one for you? Well, luckily, the researchers gave us a really handy checklist. It's pretty simple. You go with Discover if your goal is to find that one single optimal solution and you have a really clear way to measure success. But you should go with E2E if what you need is insane speed over huge amounts of data. We're talking over 100,000 tokens, and you can afford that longer training time up front. So when you step back and look at both of these paths, the message is pretty clear. The whole era of the static, frozen AI model, well, it's ending. We are definitely entering a new age of AI, one that's all about dynamic, live learning systems. And that really leaves us with a powerful final thought. True intelligence, whether it's artificial or our own, isn't really found in the static recall of facts. It's in the ability to learn and adapt to the very problem you're trying to solve, right here, right now. It makes you wonder what this new era of AI will ultimately unlock.